So I've decided to try to repair a couple of these things and make them more useful for me. I'll explain in a minute, but this thing, I think I'm gonna just try to get my money back or get a replacement. Those pins are really thin and they're bent pretty severely. I could probably straighten them out, but I'm not 100% sure that they wouldn't break off in the card later. I'm also assuming that this is correct, that these couple of pins are longer and that this one here is supposed to be shorter. That may not be the case, might be a manufacturing defect or whatever. I'll have to take a closer look at the pictures. But for now, I think I'm either gonna try to get my money back or send this one back. Strike that, they did refund my money, but I decided to take a crack at straightening it out. And I think I got it pretty close, and I think the SD card, if it does fit, will probably straighten out anything else that isn't perfectly straight. So we're gonna go gently, and boom. So not bad. I got the thing for free now. I wasn't trying to rip the person off, but it was damaged pretty bad. And yeah, so it works. These standoffs are good for things like motherboards, as I demonstrated, and they, you know, you've got two factors when you get something like this. The screw head, you want to make sure it's not going to contact anything, and the screw thread, you want to make sure it's going to fit through. As you can see, it fits an Arduino fine, but you would need, I'm guessing this is, I don't know, I'm not a metric guy, but I'm guessing it's a 5 and I need a 4 or something like that. But it will not go through the Pi 0 or the Pi, and if it did, the head would be pretty big for something like this. So what I think I'm going to do is I'm going to get some smaller head screws for these, for things like Arduinos, just to give me a little bit more clearance. Although that one would work, this one definitely wouldn't. So I'm going to get some smaller head screws of the same thread to make these things more useful. And then I'm either going to take Simple Electronics up on his offer to help me make some 3D printable versions that are smaller, or I'm going to try to find one that's an M4 or something like that. So I'm going to be doing some work to make these things more useful for these things. The next thing I ran into was this thing, and it was my screw up. I looked at so many of them on eBay that, you know, I just screwed up and got the wrong one. So what I was thinking about doing though is, you know, they're not useless. The one thing, a lot of these ATX power supplies come with 20+4 connectors to where, you know, this other one down here splits off and you can have, you know, you can use it separately. But as I mentioned, the main issue is when you put this down, there being some kind of capacitor or something like that here. Well, I wouldn't want to cut on my normal ATX power supply because I probably don't want to mess one up just for the purpose of doing, you know, some motherboard work. But what I can do is I don't mind cutting these adapters up. So this thing would actually work perfectly fine, I believe, this way, because I don't really care. I'd have to get rid of this. I'm not using these 4 pins, so I don't really care that it doesn't connect here. And then on this side, I should be able to cut this off and get it to work at least reasonably well. So maybe let's do a little bit of modifications and see if I can at least salvage my eBay purchase. Because to be honest, this is probably going to be used for a quick hookup. And even if I was going to use it for something more than that, you know, it just doesn't really matter that much. So let's get out some tools and see what we got. So the first thing, these clips are basically useless because, you know, at most are going to come in contact with something. So I'm going to take some cutters here and just get rid of them. So that should solve my interference issue over here. Yep, and I'm able to make a good solid connection there. And then, you know, there's a good chance that these pins are gonna just fall out here. So I'm gonna do my best cutting them, and we're gonna see what we wind up with. One thing I realized before I get to cutting is that I failed to mention the purpose of this connector as is to connect a 20-pin power supply to a 24-pin motherboard, which is the exact opposite of what I need. And my thought is there's never gonna be a scenario where I'm gonna do that, because if it's a 20-pin ATX power supply, it's old and, you know, was from the era where the capacitors were non-stop problems and all that. So I just don't really see a scenario where I'm ever going to want to connect a 20-pin power supply to a 24-pin motherboard, because I would just connect a modern ATX power supply. So I'm going to do a little bit of surgery. I'm not concerned at all about what happens with these wires or these pins. I may be able to pull them out. I'm going to pull the wires out now. And then I'm going to just do some surgery to try to leave me a solid border on that side. So, not the prettiest cut ever, but honestly not bad. Probably better than it had any right to be. We can see here, got a pretty clean cut on that side. So now, if I were to plug this into this junky example motherboard, it actually works pretty good. So I think what I'm going to do is I'm going to snip these ground wires from the top, and was able to salvage that one. Now, one thing I noticed is that even though these 4 wires are black on this end of the 24-pin connector, over here, those last 4 are not black. And so, as I can see, we've got what looks like a 12 volt and a 5 volt wire. One of these doubled up black wires is actually attached to a red on this side and a yellow on the other side. So I need to be careful to not just bind all these together. They need to be clipped off and protected. There's a pretty good shot of it. As you can see, they used a black wire to jumper a yellow wire and a black wire to jumper a red wire. So I'm going to do a little dab of hot glue on these wires just to prevent it from shorting up against a case or something like that, especially the 12 volt and the 5 volt wire. So I'll clean this up after I'm done. I have the glue in low temperature mode, so it's gonna be a little stringier than usual, but that should do the trick. So while it would have been a lot better to order the right cable to begin with, it turns out that cable is actually really rare, especially compared to this one, which I don't really understand. There must be some common platform out there that has 20-pin power supplies that people are trying to adapt them. But this is a motherboard like the one I was talking about, where we've got this little capacitor over here right next to the ATX power supply. So as you can see, if I were to try to plug this in, it wouldn't fit because of the capacitor. So we take this and we put it the right direction and we plug it in and then go into the ATX, and you are good to go. So fixed one of them. Now I've got one more that I want to take a look at. All right, so next up we've got this lamp and these adapters. I mentioned before that this power supply has the reverse barrel connector on there, and the plastic was just disintegrating on this thing. So I threw some hot glue on it just so I could work on it safely on the channel. But let's see here. I've started tinkering, but I haven't gotten to the point where I'm hooking up the meter or anything. So if I hook this up, it should still work. Yeah, so the light works fine. I'm gonna unplug that as well. I'm gonna unplug this. The problem was, at least the first one I grabbed, and I have a theory, so I'm just gonna go working with it. The first theory I have is that this is actually reverse polarity, which means that the hot is on the outside, which I'm sort of wondering if there was a screw up somewhere, and that's why we have this weird power supply, because like 99 times out of 100, the hot is in the middle and ground is on the outside. So this is dubiously a 12 volt 2 amp power supply, which is kind of beefy for this little LED ring. But in here I should have something that's 1.5. One. I'll pull out a bigger than 2 amp power supply. I've started just bagging these things up so the wires don't get tangled up, but this one says it's 2.4 5 amps. I haven't tried that. So first thing is I could have put maybe too small of a power supply on it the first time and it didn't work. So I am going to hook this one up and hook the barrel connector up. And I don't think it's gonna work. No dice. Okay, so the next thing we need to figure out is the other power supply reverse polarity? I'm gonna hook this sketchy thing back up. And I did bring over some of these. It's a little hard to get the meter probe in the other adapter, so I'm gonna use this thing here so I can get to it a little bit better. We're gonna take the Kaiweets multimeter, my everyday go-to meter, and we're gonna make sure we're set to DC. And we're gonna see, it's got positive and negative broken out here because positive is always in the middle, pretty much. And 52 volts. The frick is that? 52 volts. So this thing is labeled as 12 volts. I mean, you can see that 12 volts, 2 amps. What is going on here? I'm gonna check for reverse polarity. Interesting. So the polarity is correct because if I come back over here, it is putting the positive in the middle and the negative on the outside, but this thing is reading 52 volts. Huh. Okay, what now? Okay, so let's step back for a second, kind of regroup. I have a light that is supposed to run on 12 volts, but when I plug in a 12 volt power supply, it does not work. So I thought we had reverse polarity. I tested this, and this thing is putting out 52 volts, but not at reverse polarity. So I don't know if this is a mislabeled power brick or if I'm just reading the voltage with no load on it and it would drop down, or if it truly is putting out 52 volts. I don't know if it's supposed to put out 52 volts. I've got a lot of information missing, and so I'm a little afraid to just start hooking this thing up, because if for some reason this is putting out way more voltage than it's supposed to, I don't want to damage the lamp. Now, one other thing that's kind of interesting is when I look at the base, it tells me that it is made to run off 120 volts AC. So there's just all these various things here that are confusing me a little bit. And so I think what I'm going to do is step back and hook this light up to the DC power supply and see what happens. All right, so I've got the light hooked to the power supply. I've not tried turning it on yet. I am going to turn off these lights so that we can see when these LEDs start glowing. Turn off the bench lights. All right, so we are at 12 volts on the Circuit Specialist power supply, and I'm going to start going up. I'm at 14. I am at 17, nothing, 22. Oh, look at that. So at 24 volts, they're barely visible. Now as we get up here to 30 volts, which is the max of the power supply, it's pretty bright, but I can tell it is not at full brightness. So what did we learn? For one thing, I could have bridged the Circuit Specialist power supply and got it up to 60 volts, but that really wasn't necessary, because the number one thing it proved is that this power supply is a lie. There is no way that was ever designed to be 12 volts, because these lights didn't even really start kicking on until like 24 and didn't get to a decent brightness until 36 or 40 volts. So this really was a 52-ish volt power supply put in a 12 volt enclosure. And to be honest, I'm kind of glad that the thing cracked instead of melted. If it hadn't broken, I probably would have kept running the thing. Now I have filled it with glue, so it might be a little hard to do an autopsy on it. But I would imagine that any of you guys who know anything about this stuff would probably be able to tell me that this thing is definitely not set up properly for a 12 volt power supply and for the amount of current that is flowing through here. I'm gonna see if I can break this thing back open so we can take a quick look, but I don't know that I have a whole lot of hope. So I did manage to extricate the power supply from the hot glue, and as you can see, it looks pretty typical. I'm not an expert on DC power supplies, and you guys might be able to tell me something that I'm missing there, but yeah, this thing was putting out 52 volts. Now, ironically, I was thinking I might have some kind of PoE injector or some kind of phantom power adapter or something like that, but the best I came up with was this 36 volt DC power supply, which ironically did not have the right barrel jack on it, so I still had to use one of these barrel jack adapter things to make it work. But as you can see, if I plug in 36 volts, we have light. Might not be as bright as it was before, and I'll still keep an eye out for maybe a 48 volt power supply, but it works. So just to close this thing out, I wound up taking the original end off of the plug that came with the thing and soldering and heat shrinking it to the power supply, which was the exact thing I was trying to avoid when I bought these things. But in the end, everything connects up, the light works, and my house didn't burn down. I'm safe, I'm healthy, and I'm here to make this YouTube video. So hey, thank you so much for watching. Safe shopping on eBay and Amazon. Links are in the description. Have a great day.